Good morning and welcome to ACPA's Concrete Pipe Week virtual plant tour. This is our first virtual plant tour we've done, so we are excited that there's 500 elected officials and engineers joining us today. I'm Kim Spahn. I'm the Vice President of Strategy and State Operations at the ACPA, as well as I serve as the ACPA Research and Education Foundation President. Every year we celebrate Concrete Pipe Week as a way to recognize and acknowledge those in our industry, the men and women who specify, who design, who install and manufacture our product. This year, we had 15 governors and local elected officials who proclaimed this week as Concrete Pipe Week. This far exceeded our expectations for this year with COVID, because many of these governors were not recognizing any proclamations. This signifies the great significance that our products bring to communities. We thank each and every one of you for joining us today, and we hope that you are able to see something new that you've never seen before, learn something you've never heard about, and ask the questions that you need answered. So thanks for joining us today at Concrete Pipe Week on our virtual plant tours. I'm now going to turn it over to Brett Kleiber with Forterra Pipe and Precast. Thanks so much again. Everybody have a great day and stay safe.
Good morning, and thank you for joining us. We're glad you joined us on our plant tour today. This particular plant tour will cover two products, precast manholes and precast intakes. At this time, I'd like to introduce a few people that have joined me on the tour. We have Brandon Christensen, our sales engineer. We have Chad Wilson, our plant manager. Our gimbal operator is Jason Klocko. Jason, thank you. And we also have Jennifer Harrell, who is the ACPA, American Concrete Pipe Association, Central Region Engineer. Hey, Jennifer, thanks for joining us today. Could you tell us a little bit about yourself, your background, and why you decided to join the American Concrete Pipe Association?
Hi, my name's Jennifer, and I've had 21 years of experience in engineering, 8 years in the private consulting world, and then most recently, 12 years in municipal government and focused on stormwater. Through being a public servant, I was able to enrich people's lives, and I had the ability to provide a safe, non-disruptive journey to their destination. With the ACPA, I'm also allowed to do this and enrich the lives of others. So through working with DOTs, municipalities, engineers, as well as producing plants, I am able to provide a ability to enrich people's lives. Thank you.
All right, at this time, Brandon, can you go ahead and start our tour for us with the Precast Structures?
Thanks, Brett, and happy Concrete Pipe Week, everybody. As they mentioned earlier, our part of the tour today is going to be about structures. We're in Des Moines, Iowa here, and this is a facility where we make round and rectangular manholes and intakes, or inlets, depending on what part of the country you're in. In a precast factory, there's American Society for Testing and Materials. There's a bunch of different ones that we follow that govern everything that we build. So we made a quick list of the 4 biggest ones that we follow. For instance, the first one is C478. That's precast concrete manhole sections. That governs everything round that we make. 443 talks about the joints for concrete pipes and the joints for manhole sections. We're going to talk about a little bit of that later. 913 governs a lot of our rectangular stuff that we build that we're going to talk about behind me. And then finally, 923. 923 talks about the connections between pipes and the structures that they go into, resilient connectors. The next thing I'm going to show you here is what we call a shop drawing. Precasters have engineering departments that develop drawings for everything that we call MTO. It's made to order. Everything we build goes to a specific job, to a specific customer, and also has a specific purpose. So this drawing here is an example of a round manhole. So it's going to tell the plant that it's a 48-inch diameter manhole. It's going to tell them how tall to build it, but it's also going to tell them what openings to put in the structure for the pipes that are going in and out. So if you look over here, this is an example of a finished product. So the manufacturing plant is going to take this drawing and they're going to build this structure. For instance, this is a 48-inch round structure, and they're also going to put the different openings in it for the pipelines to go in and out into the storm sewer system. Behind me, to my left, to your right, is a drawing of a rectangular structure. This is an example of something here in Iowa that SUDAS calls SW501. All that means it's a 2x3 inside diameter, inside dimension structure. So here you see on our drawing, it says 2 foot by 3 foot. It's going to tell the plant how tall to build it, but it's also going to, again, tell them what openings to put in for the pipes that are going in and out of the structure. Next, we have an example of an intake, this SW501, that is kind of in progress. So if you will, on the inside form is 2 foot by 3 foot, just like the drawing shows. We have an outside form that's 4 foot by 5 foot, and that creates a 6-inch thick wall around the structure. Also, you'll see the reinforcing that we use. Everything we build has reinforcing in it. And then here are the blockouts. So these blockouts form those holes that you see on the drawings for the pipes to go in and out of the structure. Next, we have what it's almost like a mock-up of a finished product of this intake. So we put a grate on top. Many of you are familiar with these. You drive by them every day in the gutters of the street. And what happens is the rainwater dumps down into the storm sewer system. And rainwater runoff we call storm sewer. And what it does is it comes into here inside of our storm sewer structure. And from here, the concrete pipe's going to take it to the storm sewer system. We did a little bit of a mock-up of what the contractor is going to do after we ship the product to the job. So they're going to bed the concrete pipe in a rock bedding. They're going to put the concrete pipe into the opening that we formed in the structure. And then the final thing that they're going to do is they're going to do a concrete collar to seal that connection up and then continue to lay their concrete pipe out to carry the stormwater to its final destination. One more thing I wanted to point out before we go across the tent is lifting. Everything we build in a precast factory has some method of lifting it. Everything we build is way too heavy for men to handle, so it has to be lifted by equipment. So here's a really good example on. This is made by a company called A-Lock, and this is a lifting key. So what we do in the factory is we cast in the receiving part of the key in there, and the contractors that install the products, they have these keys. So what they do is they just install the key, they turn it to where it's in a safe lifting, and it cannot come out to keep them safe in the field. So this is lifting. So everything has a minimum of 2 lifting points in our factories. And then if there's something that is not able to handle 2 lifting points, from the engineering side, we can figure out the center of gravity and create up to 4 lifting points if something's really heavy. Rectangular wise too, I think the largest structure that we've built here is 20 foot by 15 foot on the inside. So just to give you a perspective of how important safe lifting is. Next, I wanted to talk about sanitary sewer. Over there, I was talking about storm sewer, and which is essentially rain runoff. Sanitary sewer is any type of sewer that needs to be treated before it goes back to where it came from. So essentially, all this stuff is going to go to a wastewater treatment plant. So if you can see up top, it might be hard to see, but we put a manhole casting on top of this, a framing grate. You drive over them every day, the round manhole castings that are out into the street. So below that is sanitary sewer manholes. So here's an example of a cone section that tapers to a 48-inch diameter. And then below that is the manhole section. And these can be varying depths from 3 feet to 50 feet deep, depending on how deep your sewer is. Over here, earlier I mentioned an ASTM standard that governed resilient connectors. It's ASTM C923. Here's an example of one. So your sanitary sewer is going to be carried in something like this, ductile iron sanitary pipe. But when it connects to the structure, it's going to have a booted connection like this. This is one of the 2 styles we use. So this boot is expanded into the structure, but it's also going to be connected to the pipe with a hose clamp by the contractor. So he's going to tighten that around this structure to prevent any infiltration or exfiltration. So no groundwater can get into the manhole and no sewer can get out of the manhole into the ground. Finally, I wanted to talk about over here, the joints and then the other resilient connector. Here's an example of a sanitary sewer base section. So the joints between the sections are also supposed to be tight. So they have what's called a rubber gasket on here, and this prevents any sanitary from getting out of the structure and also prevents any groundwater from infiltrating into the system. So when the contractor sets the next section on, this gasket is actually lubricated on the inside. It's going to roll over itself and then seal between the 2 sections. So there's a sealed connection there. And then finally down here, it might be hard to see because it's a small piece, but this is called an A-Lock, another product made by A-Lock companies. This is cast into the concrete. And when the contractor installs the sanitary pipe into this gasket actually squeezes the outside diameter of the pipe again, to prevent the infiltration or exfiltration into the sanitary closed system. So I don't know if there's any questions yet, Michael, but what I wanted to do now is just kind of turn things over to Chad Wilson. He's our plant manager here at our Des Moines operations. Chad?
All right, thanks, Brandon. Those beautiful concrete structures, precast structures that Brandon touched on and showed you today, we're poured with two different types of concrete that we both pour here at the Des Moines plant. We have dry cast concrete and wet cast concrete. Dry cast concrete will be covered at another facility later in the tour, but today I want to touch a little bit on wet cast concrete. Here at the Des Moines facility, our wet cast concrete is poured with self-consolidating concrete, or SCC. And what you're seeing right here is the basic components of that SCC. So we have cement, type 1-2 cement that comes from Lafarge Wholesome into our Des Moines terminal, produced out of Missouri. We have fly ash, which we do a 30% replacement on our fly ash that comes from National Minerals Corporation. Again, comes to a Des Moines terminal. And then we use a 3 aggregate system. So we have a 3/4 chip, a concrete sand, and a 3/8 chip. All 3 of those aggregate come locally. We are very lucky in Iowa to have great aggregate sources, and they're all within a 30-minute drive of us. Along with those basic components of our SEC, we use additives such as high-range water reducers and viscosity modifiers to help suspend that aggregate into a very flowable spread mix. SEC is much like the concrete that you see on driveways, roadways, sidewalks. When we put those additives in there, those water reducers and the viscosity modifiers, we make that concrete very flowable into a 27-inch spread versus the slump that you see out on job sites. So that concrete is working for us instead of our guys working at the concrete.
We actually have
Thanks, Chad.
a quick question here, if we can ask that. We have a couple that have come in. I think one of them might be a little too loaded or too heavy for this one, but we have one that Brandon might be able to go with, or Chad. What are the primary factors that are considered when deciding whether to use or design a rectangular or circular concrete manhole?
I can take that one. Typically, it's up to the owner or the engineer. So like in Iowa, for example, I can speak to Iowa. Most of our stuff is round just because it's more inexpensive than rectangular, plus it's more readily available. We manufacture the made-to-order items that I talked about earlier, but every single day in our facilities, we're manufacturing cones and barrels and other sections like that that are just stock material, so it's very readily available. So I would think, at least in Iowa, it's mostly round, but when you install something in a curb line, like the intake behind me, like this, it's easier for the contractor to install it on a curb line if it's rectangular, because they're running a string line behind the curb, and they know they can set this right behind the curb, and it's going to be in the right spot. It's a little bit more difficult if there's a curvature to it. So hopefully that answered the question.
Perfect. Thank you.
Before we head into the plant here, I'd like to ask Chad a couple of questions. Kind of the same thing I asked Jennifer a few minutes ago. Tell us a little bit about yourself, your experience, your background, and what do you like about manufacturing precast concrete products? All right, I can do that. So I have been in the industry for 16 years. I came into it as a college student, honestly as summer help because it was good beer money at the time. And now I'm feeding a family of 6 with it. Precast concrete is something that I've grown to love. The fact that I can build something one day, set it up, pour concrete in it, pour this material that's very flowable, come back the next day, take those forms apart and see what I built. It's also something that has grown the community around me. I've grown up around the Des Moines area, and I see projects over the 16-year period that I built. My children see projects that I built. The largest one being the wall panel that goes from the East Mixmaster to the West Mixmaster. I helped build that. My children know that, and they say, Dad built that. Their children are going to be able to say that, and my great-grandchildren will be able to say that. 75 years from now, that wall will be standing, and it's a pride thing. It's a family pride thing. With that, we're going to head into the building. As we make our way towards the man door, Here at Pore, we really stress man door usage versus overhead door. You'll see we have an overhead door open right beside us, but reducing risk, increasing safety is always our top priority. You'll also see over our man door that we have this big Pore, where are your hands sign. 70% of our injuries, around 70% of our injuries last year were hand injuries at all of our Pore facilities. And it's where are your hands? Are they in pinch points? Are they in the line of fire? It's something we preach every day to our guys to reduce those injuries and reduce that risk. As we walk into the production facility, we're going to look at some panel intakes first. As we pass by, we have a 144-inch manhole that we're going to walk by. If this doesn't work out for the contractor, then we have a nice swimming pool for the guys, 4-foot wading pool. So I think we want it to work out for them, though. The first one we come up on is sort of a basic. This is a basic setup of a 3x2 or an SW 501 that Brandon pointed out. We have our floor section that we poured yesterday. We've got our 3x2 set up. These forms that you see here are called Simon's forms. In the construction industry, they're also known as basement forms. This is essentially, they can make just about any size that we want to. We range anywhere from a 2x2 inside dimension all the way up to that 20-foot by 15-foot that Brandon talked about earlier. You can see the guys have their production drawing right here, just like we showed out on the easel out there. This thing has got its core up and we're ready to put steel on. As we move forward, just like the one we saw out there, we've got a piece that's ready to be QC'd. So we've got our 42-inch hole for our RCP opening in there. We've got extra bar around that opening where we had to cut that steel out. We use mainly welded wire mesh at this facility, and we're lucky enough to be able to do that in the state of Iowa. We have 4x4 mesh on this one, D10 and a half by D10 and a half. We also have that equivalency due to our SUDA standards that we follow. You can see we have spacers on there. We have our 6-inch wall ties to make that 6-inch space, to make that wall as we put our jackets around. Next process for this one would be to get our QC or get our management to sign off on it, check it off, go through our ACPA certified checkoff process, and then give the guys the go ahead to throw that jacket on. So that was a 6x3 structure we just saw there. We're going to move over to another 3x2. So just like the core setup that we saw, we're going to see the same thing. This one required a little bit different steel. It required an area 20 instead of an area 31. So you can see we have the 6x6 spacing here. This is D10 by D10 wire. We have that opening for a 15-inch RCP going there. Again, we have our spacers. And we have our 18-inch opening. I believe that's for a 12-inch RCP on that one. Again, that one is ready to be quality control checked, signed off on, so they can put those jackets on. Last one you'll see here is a finished, ready to pour product. So they have their whalers on the outside. What this does is help keep that wall straight. Sometimes if we have a large block out, we'll nail that to the base. Up here, up top, you can see that this panel is not going to be poured all the way to the top of the form. So we have a drag board set up to be able to pour that height. This particular piece has been signed off on by QC. The signed off on sheet is in the folder that shows that it is ready to pour. And then our pour team can come through and do their job. I think that's it for my part of the tour. I'll throw it back over to Brent.
Hey, Michael, have there been any other questions before we hand it off?
There's been a couple different questions. There's one that we'll go ahead and ask. Apologize, some of them are coming in, and I also want to make sure that people recognize great questions. Some of these are probably a little deeper than what we want to go for on this particular tour, but we will make sure someone, whether on this tour or someone else, reaches out to you and gets those answered. Brent, a question that did come in, is air entrained concrete used?
Yes, it absolutely is. Our target is always a 6.5. We range from a 5.5 to an 8 on the air entrainment, and we have an air entrainment admixture that we use to help us out with that.
Excellent, thank you. Brent?
Yeah, great. Thanks, Jason. Hey, Brent, this is Kim Spahn. We've gotten quite a few
Hi.
questions about flexible connectors or rigid connectors and what is appropriate to be used on our product and other products. Can you expand on that?
You want?
So are they appropriate to use on concrete pipe? Was that the question?
Yeah, the question is what is the best practice for connecting either concrete products or competitive products?
I think you have to look at the use. I mean, in my opinion, for storm sewer, it's not necessarily a closed system because, you know, a lot of, at least in Iowa, a lot of storm sewers are just wrapped, the concrete pipe joints are wrapped in fabric. So they want it to be what we call a French drain, or we want some of the groundwater to infiltrate into the storm sewer system to keep that water table down a little bit, because we have a really high water table in Iowa. But for sanitary sewers, absolutely, your connection should have a resilient connector, whether it's that A-lock that Jason filmed earlier or the booted connection that had the hose clamp on it. You really want the sanitary sewer system to be closed. In most places I know in Iowa, they vacuum test all those manholes. So they put an apparatus on there, suck all the air out of the sanitary manhole just to make sure it's air and water tight so nothing gets in or out of that system. So hopefully that answers your question.
Great, thank you.
Awesome. If there are no other questions, I'd like to say one thing. This virtual tour was Michael Kramer's idea that he presented to us a few weeks ago, and I'm going to be the first one to tell you that I was a little bit skeptical about how this is all going to work out, but it has been a lot of fun in the planning and getting to know people and working with all of our teammates throughout the whole process, and look forward to doing it again. It's been a great time. So if there are no other questions, I'd like to hand it off to our friends at Hancock Concrete Products in Cannon Falls, Minnesota. Thanks for joining us.
Thank you, Brent. This is Jim Grodhaus, Technical Resource Engineer for Hancock Concrete Products. And welcome everyone to Cannon Falls, Minnesota. We are located just south of Minneapolis-St. Paul, about 45 miles. Today's plant tour will include a little bit about our production of our box culverts and arch pipe. On the line with us today, we also have our Director of Sales, Scott Hofer, who's going to talk a little bit about the history of our company and how our products were created, as well as we have Matthew Steen, a quality specialist, Jake Knoll, an engineer for our company, and the plant manager, John Christensen. At this point, I'm going to turn this over to Scott to briefly talk about our company as I walk towards our production area.
All right, thanks, Jim, and good morning, everyone. Welcome to Hancock Concrete's portion of today's tour. I'd like to start out by giving you some history of Hancock Concrete and this plant in particular. Hancock Concrete was established in 1917 in Hancock, Minnesota by Henry Schmidtgall. Over the years, 3 generations of the Schmidtgall family have been at the helm of the company. Hancock currently operates 6 concrete pipe plants in the Midwestern states of Minnesota, Iowa, South Dakota, and North Dakota. The Cannon Falls plant that you're at today was commissioned in 1976. Plant and equipment have been added and upgraded over the years to improve quality and productivity. And the last expansion was in 2013. Today, the Cannon Falls plant has over 60,000 square foot under roof on this 40-acre site. Today, we're going to be spotlighting 2 of Hancock's product lines, box culvert and large arch pipe. So Hancock's history is rich with innovation, one of which is the large arch pipe. In the mid-60s, the Minnesota Department of Transportation was looking for larger arch pipe to be used to replace bridges and waterways. So Hancock worked with them and designed the world's largest concrete arch pipe, which is 169-inch span. It's got a 100 square foot opening. The Highway Department referred to the large arch pipe as the Schmidtgall arch for many years, since no other companies produced that size of pipe. In addition, you may be interested to know that in 1974, Hancock worked with MnDOT to design, build, and install the first precast box culvert in the state of Minnesota. Hancock and other ACPA member producers in Minnesota work closely with MnDOT to update and improve standards to ensure that the traffic public and the taxpayers receive the best value for the cost and a resilient infrastructure. All of our plants utilize local raw materials such as aggregates and cement, as well as a labor force of around 250 company-wide. As Jim enters the plant here and is going to pan up to the wall, we're going to look and see our core values of our company, which are very important to us. So you can see them stated there above the lunchroom door. Our core values of integrity, long-term relationships, a culture of opportunity, and strong work ethic. And on the right is our 4 unwritten rules: no swearing, no jerks, we enjoy what we do, and we have fun. Now, I hope so you're going to have some fun on this tour. And with that, I'm going to turn it back over to Jim.
Great. Thank you, Scott, so much for the introduction. We're going to move right into our production line here, and I'll have John Christensen take over and describe what you're seeing on the video feed. John?
Morning. This is our mixer truck. This is how we pour. We have an in-house batch plant, and we pour with that along with that 2-yard bucket right there, which is a remote control bucket provided by New Hampton Metal Fab out of Iowa. It's run there by our overhead cranes. Everything we do in this plant is with overhead cranes. The cage to your left is a standard 10x6 Class 2 cage. You're looking at a piece of duct tape there with all the dimensions wrote on it by QC to make sure that it meets all specifications. Also on this cage, you're going to see the spacers that hold the spacing 5-inch on the interior with bolsters. And on the exterior, we've got either the round wheels, 1 3/4, or the poly snaps provided by Strike Tool.
Question, John, or maybe for
Yes.
Jake or Matthew, how do we know how much steel to put into our cages?
You want to take that, Jake?
You might be on mute, Jake.
We know how much steel to put in our cages based on the design. MnDOT has standard designs for that, so we follow those standard specifications. That's how we know. Or if it's a special design, our in-house engineers will design that. So now as you're walking across, you're going to see another 10x6 core set up here. This is at the point right here where QC is going to double check it again. Even after that, they're going to check this again to make sure that the tie pin holes are in it. Make sure there's enough poly snaps on it. Make sure all the spacers are, make sure the wall thicknesses are correct. That is one of the PVC for the tie pins. As we pan around to the back, we do use PVC for our lay holes here. That helps assist in laying it, but also as we tip it off the form here. As we walk around, this piece of pipe right here will weigh in excess of 20,000 pounds. This is just a jacket waiting to be sat on the form. As soon as it passes QC, they'll let them know to put it around there and pour it.
We're going to walk outside the plant here over to our quality control area. Again, using the man doors for safety purposes. Entering door 17. And I'll ask Matthew to jump in here regarding quality and how we assure the strength of our concrete.
All right, thanks. So the first thing that you're going to see as we walk up here is we call that a cylinder rack. And basically what those cylinders represent is a sample of the batch that is used to create the products. Usually a batch represents about 25 yards of concrete. That one that you're looking at there is a dry cast cylinder formed on 7/21 out of batch number 19729. And basically what these cylinders do, depending on the class of the structure that is poured, these are going to be the strength representation that goes with those products through day 1 through day 28. So for example, tomorrow they're going to break cylinders that were cast today. They're going to put them in the machine that you're looking at right in front of you, the big blue machine there. And that is going to create a load on that concrete cylinder until it breaks. Once that's broken, it's going to record the PSI that has been used to break that cylinder. And then again, depending on the class of that concrete, it's going to basically verify that that can withstand the amount of strength required for that to be used in the field. So we'll break them on day 1, and then the last one we'll break is on day 28, and then intermittently throughout there, to verify that the concrete has the recommended strength to go out into the field, and no concrete structure will be sent out until the strength has been met.
Matthew, could you briefly explain how we interact with our DOT here?
Absolutely. So we have a Minnesota DOT inspector on site at all of our plants 24/7 when the plant is in operation. And the reason for that is a lot of our DOT jobs, number one, are inspected by our quality team, and they're also inspected by the Minnesota DOT inspector to ensure that the jobs are, structures that are made for those jobs are adequate to perform that. And then the Minnesota DOT inspector will actually put his stamp of approval, or their stamp of approval rather, on the concrete structures that go out in the field.
Great, thank you. John, you want to describe what's going on here with these these pieces?
Well, these pieces here have been put through our 3-edge bearing tester. These we put an ultimate deload on, and after that happens, these pipe are put out here to be cored to verify the core strength and the steel placement. So that's what these pipe are here. These are waiting to be cored.
Thank you. Let's highlight on something that's a little bit different about our plant here in Cannon Falls. You want to describe what I'm walking into right now, John?
This building is currently under construction. This is a project Hancock is really excited about because with the COVID-19 and our truckers, we recognize they're one of our biggest assets. And with Morel Transfer out of Elk River and Lefebvre Transportation out of Elk River, and the truck stops essentially, a lot of them shutting down to the truckers. They have no place to go. And they're typically on the road about 5-6 days a week. So this is our shower house. It's got a nice big shower in it, 4x6 shower, and it's a laundry room. This is going to be a place for them to go. There'll be an awning out front, a grill, a slab, and whatnot. So it's kind of a home away from home for them where they can go.
That's great for us to.
Hey, Jim, we are having a couple questions come in. A lot of these are really, really good, and I think more in depth again. But here's a good one that we had. Can you tell us the difference in mixed design between wet pour and dry pour? Keep it high level, but the difference between wet pour and dry pour.
John, you want to take that, or Matt?
Yeah, either one. The biggest difference is water to cement ratio. That is the biggest difference. The wet cast is your traditional, what you pour your sidewalks and stuff like that out there with. Dry cast is a lot drier. It has more of a water to cement ratio. Can get down into that 0.23 and whatnot. So it's a huge difference. One's dry, one's wet.
I do know that in the next part of the tour with Riley from Forterra, he's going to have an example of what dry cast looks like and what that entails.
Hey Jim, another good question while you're on wet cast and dry cast that I think helps follow up is, how do you cure the concrete and how long does it take, wet versus dry?
Curing time is relatively about the same. Dry cast, typically, about 18 hours, we meet our design strength on dry cast. Those are typically right after they're poured, they're all covered up. The same as our wet cast, they're covered up, a 3-hour wait time, and then we go ahead and apply steam at a certain rate to them.
And what is that compressive strength of concrete?
Depending on, so a standard dry cast pipe require 4,000 PSI. And you can get like class 5 with 6,000 PSI. Your box culverts here have a standard of 5,000 PSI, but when you get up into some of your higher classes and higher fills, they will be 6,000 PSI.
Great questions, thank you. So John, what am I standing in right now?
here you're standing in a 12 by 11 box culvert produced for landwehr construction. It's 12 by 11. It's not the biggest box culvert that Hancock's makes. The biggest one that was produced at our Hancock facility was a 16 by 12 double cell back in 2016, but we do make them up to 24-foot span and 17-foot rise on them. This is a 9 by 5 that we just put together here to kind of illustrate how this is out in the field, what the contractor, what he's looking at as far as the mastic, where the mastic is placed. As you see here, the mastic is placed in the center of the joint right there, and it goes into the haunch, dead center of the joint, into the haunch. And this is on the flow line, but MnDOT requires mastic all the way around on their joint. So as we go to the outside, we'll see how we replace that also. And then of course, the next one is the tie rods in there, and then the joint actually together. So you can either have your tie rods, depends on what the municipality wants, whether it's inside out or outside in.
We had a quick question based off a vocabulary word. What is mastic?
Mastic is the joint sealant. It's a butane mastic. This particular one is 1 inch by 1 inch that is put into the joint. It's a sealer. You'll see it. We call it mastic. This particular one is the filter cloth that goes over the top of the product. The contractor would apply an adhesive and stick this right to there prior to backfilling to ensure that that filter cloth stays there. That ensures that there's no infiltration of dirt and sediment. So
here's the other part of the mastic, John. Obviously, it got a little hot. And
it looks like it dripped off. Yes, it fell.
But
fell that off. Would come all the way. That fell off. That would come all the way down. That's that butane mastic, inch by inch, that is set in the joint.
I think our time's coming to an end here, but let's briefly show our
115-inch arch pipe here. This is standard arch pipe that we produce. We produce all the way up to 169 inch. This is 115. Shows you a number 2, a number 1, and a 6-foot barrel section.
All right.
Hey, Jim, I have one more question for you, if you don't mind, before you jump over.
Please.
What are, just with regards to the outside, is there any finishing that's done to the surface, either to make it look a little bit neater, smoother, or anything like that? Or is it just kind of go in as is?
No. The surfaces are mudded. Like this one here has not been prepared yet. They get mudded and all joints are sealed up. And then of course, anything bigger than, let's call it the size of a dime, bug holes are filled. This one we just pulled right off production, and brought it over here and marked it.
Well, we do have a continuous patching crew that will work.
Yes.
Probably 1 or 2 of them at each of our plants.
Correct.
Yeah.
Another great question that came in, Jim, is how that goes to the finishing look. How is concrete consolidated in our plants?
In the wet cast is consolidated with high frequency vibrators that hang on the form. Is how those are consolidated. Over on dry cast, they're internal low frequency vibrators that force it down.
Anything else on the chat, Michael or Kim?
Oh, we got tons of stuff, but we'll let Riley take over, and we'll start to ask him some of those questions too.
All right. Well, we'll thank you for joining us at Cannon Falls, Minnesota, and we look forward to our next virtual tour. And now I'll turn it over to Riley Dvorak with Forterra out of Elk River, Minnesota, which is about 70 miles northwest of Cannon Falls. Take it away, Riley.
That's right, Jim. We are north of you guys in the great Midwest. So who knows? Maybe we got a chance to see some snow today. You guys, everyone that's tuning in and watching, you guys are getting a good taste of what I think is the better part of the country. So I'm excited to show you guys some pipe production today. But before I do that, I'm going to show you guys one of my favorite people here. This This is Brian Olson. Brian, I'm going to ask you a few questions here. Why don't you start by just telling us a little bit about yourself? How long have you been with the company, and what do you do?
Oh, sure. First of all, welcome to Elk River, Minnesota. And as Riley said, my name is Brian Olson, and I have been doing this for about 45 years. Started with then the Precast companies, working in the summer as a college, between college and college seasons. And so my current role is operations director for Minnesota and North Dakota for Pore.
Cool. What do you like most about what you do, Brian?
Well, certainly it's working with the people. We encounter a lot of problems, that our customers, trying to meet our customers' needs, and certainly working with people to be effective in what we do, be safe, produce a quality product, take care of our stuff, and hit those production targets that we need to hit. Yeah. So very challenging, but also very rewarding, helping people be successful.
Absolutely. That's great. So tell us a little bit about Elk River. What are we going to see maybe today? What do we do overall here, and maybe how long has this facility been around?
Well, the Elk River plant was the first of the Precast plants. Started in 1917. I've been here a while, but I wasn't here when that started. But and this is also one of our more diverse plants. Here we manufacture pre-stressed concrete beams for the state of Minnesota and sometimes outside the state. We also produce box culverts and dry cast pipe, wet cast pipe, and manholes as well. And then we tend to enjoy taking on a special project every once in a while. We have a lot of talented people here at this facility and good leadership, and we're able to tackle some of those very challenging products.
Yeah. Yeah, we certainly are. So we're going to go, just today, we're going to be watching some dry cast pipe production. So for all the people watching, what's one thing you want people to learn or take away from what they see today?
Well, really, concrete's the way to go. I'm sure I'm biased a little bit, but frankly, concrete has withstood the test of time.
Yeah.
It's an extremely durable product. I know our MnDOT, our DOT here in Minnesota, loves concrete girders, not only from their aesthetics, but also low maintenance and great field performance. Concrete pipe stays in shape. Engineered, highly engineered product, very, very good proven track record. So I'm sure I'm a little bit biased, but the fact is, it is a great product. And I really want to drive that point home.
Yeah, awesome. No, that's great. Thanks for sharing, Brian. We're gonna head out. You have yourself a good day, and we're gonna hopefully go learn something. Everyone that's on the call, I hope you guys were listening closely, because there will be a test at the end of the tour. I got to put my PPE on, and then we will head out to the plant. All right. So as Brian said, we do make a lot in this facility. We make pipe, bridges. Hey guys, how's it going? We make box culverts and a ton of specialty stuff, but what we're going to be looking at today is just pipe. Oh, hey, this is why you use doors and not the overhead, right? Hey, Jake. Hey. All right, so we're going to be moving through. We make a lot of very heavy stuff, so you'll see a lot of really big equipment here. We make all of our large diameter structures here, so you can see our manhole setup right in front of me here. I am making my way over to the dry cast pipe building. That is a big building that we see in front of us here. So you see up to the left, that is our batch plant. So that's where we mix all of our concrete. So that's really where the process starts. We've got silos and things that have all of our aggregates and sand and cement. And that is what we mix into our pipe right away. So the first step of the process, the first thing I really want to show you guys is when it comes to pipe production, it really starts with a cage. Okay, so that's what we've got in front of us here. This is a
arch cage. This happens to be a 29 span arch. A lot of what we do here in Elk River is with 2 cages, but this happens to be a single cage product. So there's a few things that we're concerned about when it comes to our cage. Number one, the diameter. And you guys saw over at Hancock, they had measurements written on their cage. And those are very important. Those are measured with micrometers, just to make sure that the diameter of the wire that we're using is sufficient and as per design. We also want to keep an eye on the spacing between the wires. Obviously, if wires are spaced closer together, that gives you higher strength. And the last thing we're worried about when it comes to cages is the position of that cage within the wall. So we want to make sure that that cage, for obvious reasons, is not too close to the surface of the pipe, where the steel could potentially corrode over time. We also want to make sure it's not too far into the wall where we're losing strength. Because if you know anything about reinforced concrete design, it's that our product gains most of its strength from the steel itself. Concrete's very, very strong in compression, but it's pretty weak in tension. So we need the steel to be in those areas of our product that experiences the highest tension. So if it's not in the proper location, we can lose a lot of strength because of that. So to keep it in the proper place, what we do is we have these spacers. These are metal spacers. This one is making sure that the cage isn't too close to the outside core, and it's not too far away. And that's this spacer over here is the inner spacer, so that's keeping the cage away from the inside core of what will be the finished product. So these 2 devices are used to control the position of this cage. Obviously, if we had a 2-cage set up here, you guys would see that the outer cage would have these spacers on the outside, and the inner cage would have these types of spacers, keeping the inner cage away from the inner surface of the pipe. But really, the neat thing about that is that the cage itself really determines the strength of our product. We can keep everything else equivalent. We can use the same shape of pipe, same wall thickness, same concrete mix design, and we can go, just by changing the steel, we can go from a class 2 to say a class 4 pipe. So there's a lot of strength that is gained by that, and it's really important that we keep the wire diameters the same, the spacing the same, and we've got the position within the wall the same as well. So that's where things start. Now we're going to get to see some pipe being made. So it looks like they're kind of getting set up here. I'm going to go around, so follow me this way. I'm going to note here, this is what we use to make our tongue on the top of the pipe. So this is a joint ring. The inside surface is what forms the joint. So this is what we'll see in a little bit. This gets lowered over the top of the finished product to form the joint. So I'm going to come
Riley,
in
we have a quick question for you that I think you would be able to answer well.
I hope so.
Being that you are in Minnesota, a place with some extreme seasons, we'll say, how does your production processes vary with the different seasons? Do they change? Are they relatively normal, or you just live under a big heat bubble in the winter?
You know, I'd like to say we live under a big heat bubble in the winter. That sounds really pleasant. In the winter, unfortunately, a lot of our facilities have to we lay people off. You know, most of our workers here plan on that as part of their routine for the year. But what we do is we've basically got 9 months of production to get all of our, you know, just like our construction season is shortened just because of the winter, so is our plant production season. So most of what we do gets shut down. However, a lot of our indoor operations, if need be, can continue on. So the building that we're seeing here could potentially be functional. The hard thing is, if we're doing that, we have to heat up our aggregates. Everything that we get imported into our concrete mixes has to, there's some extra work that goes into it. So it's a little bit more costly to run in the winter. We can do it indoors, but we don't always do that here in the way up north.
Thanks.
So no, great question. So I am just going to peek at things through the window here, simply because I think as soon as I go in, I lose signal, and you guys will lose some quality. So actually, I'm not getting the best view here, so I'm gonna move around so I can picture it through the door here because we'll have a much better angle to see what's going on here. Let me try to get out of the light. Can you guys, is my video coming through okay? I know it's kind of bright.
It's okay, Riley. If you could take a step farther, one step farther forward, that might be good. But otherwise, we can see it relatively well. Yep.
Okay. All right. I'm going to kind of be in the middle of things. Hopefully, my video doesn't slow down here. You can see over here, that's the jacket that forms the outer surface of the pipe. What they're doing right now is, looks like they just set the cage down, and they're getting ready to pour a piece. So we're going to watch this a little bit. What happens? No, actually, I take that back. That green jacket looks like they're not running that one right now. We're running this 29 span one right here. Okay, so they just laid that piece of pipe. I've got to move out of the way because they're pushing these carts home.
Hey, Riley, while we're watching this process, there was a great question about what is the biggest reason to use dry casting versus wet cast?
From a production process, it's just far more efficient. We can crank out quite a bit of pipe in a much more timely manner. It's a very precise process. So what you see here is very consistent. These pipes are identical. There's no way to tell these apart. So it's a very highly innovative process for high efficiency, and I guess from a manufacturing standpoint, this helps cut our costs down so we can supply a quality product at the best price we can. So you can see that piece of yellow equipment that's standing up there being suspended by the cranes. That's the jacket. And what they're doing right now is they're lining up a cage so that the jacket can receive that cage. So it'll lower over the cage, and it'll pick up the joint ring, which is beneath the cage, and that whole assembly is going to be lifted up. So let's watch that, and then we get to see how they form a pipe. So that operator right there is controlling the crane. So he's got control over that jacket. He's ensuring that all the it's going to get a little loud in here now. Hope I don't lose you guys. So as you can see, he just picked up that cage. So we'll take a look at 280 cage here. So that cage and that form gets lifted overhead. And we'll see over here, that right there is the door. So that's the form of the container system. Like that yellow piece of equipment, that's the jacket from the outer system.
Hey, Riley, I think we've lost a little bit of your audio. You might need to step back out of there a little bit. We see the video, but we're not hearing you quite as well.
Yeah, I was going to mention, I think to interpret what Riley was saying was that they were lifting the jacket overhead, and now they are placing it on that inner core that will form the inside of the pipe. And so that jacket's now going on over that inner core.
They moved the trays here, so I got a better view from the door here now, so hopefully you guys can hear me okay. So they just lowered the cage, and they kind of drop it to the crane and detach it now. Now the operators just checking to make sure that cage is centered, just pulling everything down to get ready to work. So,
we're still having a hard time hearing you, Riley. I'm not quite for sure why at this point.
Okay.
I don't know if you need to bring it a little closer to you, or maybe you lost connection with your headset, but you're still sounding pretty distant.
Yeah, so while Riley's working on his sound there, they're actually, if you see that little yellow sloped piece there, they're pouring the concrete right now into that form. And I want you to take note of how quickly this entire process happens, which is what Riley was talking about, the efficiency of dry cast.
Well, I apologize if you guys can't hear me. Tim, thank you for stepping in and describing some of that for us.
We hear you distantly, Riley. Go ahead and keep talking, and while it's quiet, we'll be able to make out what you're saying.
Sure. Yeah, I don't want to. I talk to myself enough as it is, so hopefully you guys can hear me. So right now that form is getting filled up. What they do as that form is filled with concrete, is they turn on vibrators, and that helps consolidate the concrete into place. That's, again, a dry cast mix. We'll get a look at that in a little bit as to what that looks like, what the consistency of that is, but it's a very dry mix that requires a lot of energy to consolidate into place, to make sure that we get all of the voids out, that we got a really dense mix at the end of the day. So generally speaking, our concrete mixes are 4 KSI. For some of our higher class products, we go up to a 5 or sometimes 6 KSI mix. The nice thing about that, and I'll mention this in a little bit too, is we get those design strengths in 18 hours, and I think that was mentioned previously. But our concrete, just like any other concrete, it doesn't stop gaining strength. So our 28-day strengths are oftentimes 50% higher than that. So we can get 28-day strengths on a 4,000 KSI mix of 6,000 KSI, and that's above and beyond what any designer intends. So there's really a lot of robustness built into our product that we take a lot of pride in. So right now it looks like he's getting to the top. He's just putting those last bits of concrete kind of where they need to go. He's able to kind of play around with it. He's got a lot of experience, so he knows about how much to go on either side of the pipe. You know, there's a little unevenness as the mud was distributed around the pipe, but it's getting close to the top. So what'll happen is he'll make sure there's enough to form the joint, and what we'll see eventually here is he's going to press that joint pallet, one of the ones that we saw earlier. In fact, it might have been even one of the ones we touched, that they pulled up, and they're going to press that down onto the product to form that joint surface. Now these are arch pipes, so the joints are a little simpler. These are just tongue and groove joints. Currently, we're not manufacturing anything, any arch pipe with gasketed joints. So these are just kind of a flat surface, a very simple joint. And those will be sealed with that mastic that we saw earlier. But we'll also get a look at what some finished gasketed joints look like. Those are a little bit different in shape and certainly different in performance. So he's going to manage the mixer, make sure that the conveyor is moved out of the way, and then he's going to start getting ready to put that top joint ring on.
And as we have a quick break here, I just want to know we are at 1 hour. We'll probably last another 5 or 10 minutes at the most here for those who can stick on. For those of you who have to jump off, completely understand. We'll send out a link so you can see the very end of this. Also, make sure that you send in your PE number to acpa@concretepipe.org if you didn't do that on your registration, to make sure you get the PDH. Riley, we'll turn it back over to you.
Thanks, Michael. I was going to check the time right after we were done here, and I didn't think we were going to be this long, but you can see now that he's pushing that joint ring down, or just getting it set in place, and then there's some hydraulic controlled rams that end up pushing that joint ring down to make sure that surface is even, smooth, and that the concrete's consolidated all the way around it. So I'll move on just for the sake of time, but in a few seconds here, what we'd see after he presses that joint ring down is that entire jacket will get lifted up with the pipe in it, and it would get placed on one of these trays, and these are our curing trays. So what happens is at the end of the day, we push these trays, kind of as I was standing on them, they were doing it, but they push these trays over there into a kiln, and that's where our concrete is steam cured overnight, and we tip it out in the morning for stenciling and detailing. So that's where the end product kind of comes out on the back end of the building. So I'm just going to close out by going over a few displays that we've got over here. So this is a couple pieces of 48-inch pipe with two different styles of joints. We've got an O-ring joint right here. This has a little groove to receive the O-ring rubber gasket. And this is a profile style gasket joint. It's basically just a single step, and that's where the gasket sits on. And I think we saw a little bit of that earlier, where the gasket rolls over itself. It's a very construction efficient joint where the contractors don't have to spend much time greasing things up. They'll be able to set the joint and continue on unhindered. So these, either way, those are both gasketed style joints that basically means they meet the requirements of ASTM C443, and that's a rated joint for 13 psi or 30 feet of head, which is more than enough for storm sewer conditions. It's actually a very, very high performance joint, something we take a lot of pride in. To get that kind of performance consistently, we keep our joint dimensions, our tolerance on those joint dimensions, plus or minus 50 thousandths of an inch. And that's an incredible thing when you think of how robust these joints are, the fact that we're using concrete to make them. Some of these, have spans of up to, 10 feet, and we're keeping that really tight tolerance. That's less than a 16th of an inch on any given dimension within the joint, which is incredible when you think about it. So we take a lot of pride in our joints, and we hope you do too. So just a couple things to finish out. This is our dry cast concrete mix. It's a zero slump mix. The really amazing thing is we can have freestanding pipe just after we consolidate it, after everything gets shaken into place. As Jim pointed out to us earlier, all of our pipe, even though we've got our QC to keep our cages right where they need to be, making sure we've got the right wire sizes.
Riley, I think you just went on mute. If you can unmute your phone.
Yep. Riley, I think you unintentionally muted yourself there. Oh, there you are back, Riley.
Here's a dry cast mix. This is what we were reported earlier. As you can see, a very, very dry type, and kind of the consistency of maybe beach sand with a certain amount of wetness. But the fact that we can get this to stand 8 feet on end without tipping over is a pretty cool science experiment or accomplishment of science, which I just think is really, really neat. Well, thank you guys for letting me go over time. I'm really excited about Pipe Week. Really excited that I've had the opportunity to show you guys our Elk River facility. Michael, do we want to answer any questions? How do we want to close things out? Because I guess we're a few minutes over time now, but
you know what, Riley?
I want to
go ahead, Ken.
I did have one really good question that I thought was a great overall big picture question, and that is, what is the typical lifespan of these concrete structures, and how long are they designed for and expected to last?
Excellent question. So the great thing about concrete is we've been in industry for over 100 years. So we have products that have been in the ground for 100 years. So that's generally what we say is our life expectancy is a proven 100-year design life. And really concrete, as we know, gets harder and harder over time. So the product itself is getting stronger. So if it's left undisturbed, there's no reason any of these pipes necessarily need to come out of the ground. So they're a very high performing product, and at the end of the day, 100-year service life is not a problem for us.